In a place where mountains carve through the landscape and roads are more like perilous paths, one ambitious project dared to defy nature. Imagine splitting a mountain in half to build a bridge that stretches higher than anything before it. But what drove this radical move? What kind of challenges could push engineers to literally tear the Earth apart? This isn't just another bridge, it's a gateway to the future. Stay tuned to discover how this groundbreaking feat of engineering is changing the game. The challenge of the terrain. The region where this bridge now soars is a landscape dominated by steep mountains, deep valleys, and jagged cliffs. More than 90% of this province is covered in hills or rugged terrain, leaving almost no flat ground for traditional roads or bridges. For centuries, residents had to navigate winding mountain paths that could turn a short journey into hours of slow, exhausting travel. This isolation wasn't just inconvenient, it limited economic growth, access to services, and opportunities for the people living there. Building infrastructure in such a hostile environment presents serious difficulties. The mountainous topography means every meter of road or bridge must be carefully planned to avoid unstable slopes, rocky outcrops, and sudden drops. Unlike flat plains where highways can stretch endlessly, here every route encounters natural barriers that force detours or engineering compromises. Simply put, this is a place where conventional construction techniques frequently fail or demand extraordinary effort and cost. Given these challenges, the idea of splitting a mountain might sound extreme, but it reflects how standard solutions were no longer viable. This wasn't just a question of building a bridge or a road in a difficult spot, it was about rewriting the rules of what was possible. The true scale of the obstacles makes the eventual solution all the more astonishing, and it's only by understanding the setting that the boldness of the next steps becomes clear. Even with such daunting terrain, China's ambition to better connect this region pushed engineers to think differently. And this meant aiming for more than just a bridge. Engineering the world's highest bridge. The answer to spanning this vast canyon was a record-breaking bridge that would defy conventional limits. The Huhan Bridge stretches nearly 3 kilometers across an enormous gorge and stands 625 meters above the river below, higher than any other bridge on the planet. To give some perspective, that height is roughly twice that of the Empire State Building, making this not only a transportation route, but also an extraordinary feat of modern engineering. Its main span stretches over 1,400 meters, demanding a design that could handle incredible loads and forces. Engineers debated between two primary designs: cable-stayed or suspension. While a cable-stayed bridge features tall towers with cables supporting the deck directly, the suspension model was selected for this project. This choice was practical, especially for a location with rocky mountainous terrain, because suspension cables can be anchored deep into hard rock, providing unmatched stability in such unforgiving conditions. The final design relies on a steel truss suspension framework consisting of 93 truss sections, collectively weighing over 22,000 tons, more than 3 times the weight of the Eiffel Tower's steel structure. Constructing such a massive structure at dizzying heights brought its own challenges. Materials had to be precisely positioned, often high above the canyon floor, where even minor inaccuracies could endanger the entire project. Rather than rely on the world's largest cranes, engineers used an overhead cable crane system, a complex monorail-like cable mechanism, to deliver and install heavy steel sections. But building the highest bridge was only part of the story. The path leading to it through the mountains required something equally groundbreaking: cutting through the mountain. The surrounding mountains offered no natural gateway for a highway, forcing the project team to take extraordinary measures. To forge a direct route between two key districts, engineers literally split a mountain in half, carving a V-shaped cut large enough to accommodate the expressway. This was no small task. It involved massive drills and carefully controlled explosions to break through solid rock while preserving stability. The goal was to create a passage that would save drivers hours of winding, dangerous travel by allowing vehicles to move straight through the heart of the mountain. This mountain cutting wasn't done haphazardly. Months of geological surveys and planning went into determining the exact location and shape of the cut. Soil conditions, rock strength, and the impact on neighboring slopes were all critical factors. The resulting trench connects 14 interchanges along a 150-kilometer highway that slices through what was once an impenetrable barrier. The precision of the operation ensured the road provides safe, reliable access without triggering landslides or damaging the surrounding environment. While it may seem astonishing that a mountain could be split open for infrastructure, this action was the key to unlocking the entire region's future. It links up directly with the world's highest bridge, completing a transformation from isolated wilderness to accessible, modern transport corridor. The battle against natural challenges didn't end with cutting rock. It extended into managing the forces that constantly shape this landscape. If you're fascinated by how engineering defies nature, don't forget to like and subscribe for more groundbreaking stories. Overcoming environmental challenges. Building the world's highest bridge over a massive canyon presented major challenges, particularly with the region's seismic activity. Engineers designed the bridge to withstand earthquakes by installing hydraulic shock absorbers to reduce swinging from seismic forces while maintaining flexibility for temperature and wind changes. Wind was another significant challenge. The canyon acts as a natural wind tunnel, speeding up gusts that can reach train-like speeds and apply immense pressure on the structure. To understand this, engineers built scale models and conducted wind tunnel tests to analyze airflow patterns. An advanced technology, Doppler LiDAR, was also used to map wind currents by tracking moisture particles. This real-time data allowed engineers to better understand wind behavior and how the bridge would perform under extreme weather conditions. By considering seismic shifts, strong winds, and uneven terrain, engineers ensured the bridge's safety and stability both during construction and for years to come. Even when the greatest risks have been planned for, a structure this immense demands constant vigilance to ensure it stays safe for years to come. Monitoring and maintenance innovations. The bridge's cables are among its most critical elements, holding up the enormous weight of the steel deck suspended hundreds of meters above the canyon floor. These cables endure tremendous strain, and even small changes can signal potential issues. To monitor their condition precisely, fiber optic strands are embedded within the cable bundles. When the metal strands stretch under load, the fiber optics stretch too, changing the way light travels through them. By measuring these light reflections, engineers can detect tension variations in real time, allowing quick responses to any structural concerns. This continuous monitoring is vital because the mountain setting is far from static. Temperature fluctuations cause the bridge to expand and contract, while natural wear and tear stress materials in ways that traditional inspections might miss. The use of fiber optic strain gauges has revolutionized maintenance by providing detailed ongoing data without intrusive checks. In addition to these internal sensors, workers regularly inspect the structure from a catwalk that runs atop the bridge, navigating dizzying heights to ensure every connection remains secure. These technologies combine human skill with cutting-edge science, turning the bridge not only into a feat of construction, but a living system that engineers can watch over closely. As impressive as the initial build was, ongoing maintenance powered by real-time data gives this record-breaking bridge its greatest chance at long-term success and safety. With safety secured through careful monitoring, the story of this bridge extends beyond engineering into the impact it's poised to have on the region's future. Bridging economies and cultures. The Huhong Bridge connects a previously isolated region, slashing commute times from hours to minutes and unlocking vast opportunities for local communities. Once cut off by rugged mountains, the area is now linked to major transport networks, boosting trade, tourism, and investment. This infrastructure project is part of China's broader strategy to alleviate poverty and promote development, aligning with the Belt and Road Initiative to create global economic corridors. Tourism is also a key factor, with features like a glass elevator, a cafe with breathtaking views, and a glass-bottomed path across the canyon. Plans for extreme sports, such as bungee jumping and base jumping, are set to turn the bridge into a major destination. What started as an engineering marvel is now a cultural and economic catalyst, transforming the region's future. When cutting-edge engineering meets nature's toughest challenges, it opens new possibilities that extend far beyond just the structure itself. This bridge is more than steel and concrete. It's a story of ambition, innovation, and connection. From splitting a mountain in half to building the tallest bridge on Earth, China has redefined what's possible in infrastructure. The Huhong Bridge not only rewrites maps, but also promises a brighter future for the communities it links. If you found this journey through engineering fascinating, don't forget to like and subscribe for more stories that shape our world.